Again, in example 3, I'm given a graph, but this time it's not geometric in nature. So now I just have this polynomial shape, but I know the area here is 4. And now here where it says the area is 9, I'm going to have to pay attention to the fact that it's under the x-axis. So actually this is going to give me -9, and then this area here is going to be 2. So I already have the areas. I don't have to do the geometric calculations, but I am going to have to use my fundamental theorem of calculus. So I was given the point 35, and again, I'm being asked to find f of 0 specifically. So I am going to use the 3. I also need to use the 0. And because this is f prime, to go backwards from f prime to f, that's going to mean I'm going to integrate. So we're going to say that we're going to integrate. We always want to go from left to right. And this is where it gets just a little bit more challenging than a couple of the previous ones that you've seen. So again, applying the fundamental theorem, this would be f of 3 minus f of 0. But in this case, I'm looking for f of 0, and I'm trying to find, or I already have f of 3. So moving this around requires a slightly different algebraic take. You can't just add this over here and be done, because this is the thing you're looking for. So what we're going to do is we're going to add this to the left, and then we're actually going to subtract that over. So we're going to end up with f of 0 equals f of 3 minus the integral. That's just an algebraic manipulation is all that is. So again, I added, I'm going to do a slightly different color so you can see it. So what I did was I added f of 0 to one side, and then I subtracted the integral to the other side. And that's how I ended up with what I have now. So I do not have that area, and I also know what f of 3 is. So f of 3 was 5, and then the area from 0 to 3 was 4. So that's how I'm going to get 1 as my f of 0, my actual point 0, 1. So let's go ahead and do the next one. So now I've got f of 7. Again, I'm going to use the given, and I'm going to go from 3 to 7. And I'm going to integrate f prime. And using the fundamental theorem, that's going to give me f of 7 minus f of 3. So now if I'm trying to isolate f of 7, I'm just going to add the f of 3 to the other side. So we're going to get f of 7 equals f of 3 plus. So in this situation, we're actually adding. Now the integral from 3 to 7, the integral from 3 to 7 is going to be 9, but it's -9 because it's below the x-axis. So we could do plus a negative if we wanted to make sure we're clear about that. But either way, we could also get 5 minus 9, but we should get -4 on that one. And then we're going to do f of 9, and we're going to make sure we include all the pieces. So f of 9, I'm going to go back to 3 because 3 was the given piece. And I'm going to integrate f prime. And I'm going to get f of 9 minus f of 3. So I'm going to move that f of 9, that f of 3 over to the other side. Let me do this correctly. I'm going to put the f of 3 on this side just to make sure that I can see everything clearly. So f of 3 is 5. Then the integral from 3 to 7 was -9, and the integral from 7 to 9 is 2. So altogether, this is going to give me a -7. If you want to write it out as 2 pieces, you're more than welcome to do so. But if you just want to push those together into -7, that's fine also. So either way, you should end up with a -2. So now you have your specific points. So I have 0, 1, I have 7, -4, I have 9, -2, and then I also have 3, 5. And that would be what we used here to graph those. So let's see if we can get that together. So I'm just going to do my x's and my f of x. So 0, -1 was given, 3, 5. That was the given piece here, just to make sure y'all can see that. So 3, 5 was a point that I had. Then I had the point 7, -4. And then I had the point 9, -2. So I'm going to go ahead and place those points on. I'll go ahead and give myself a small scale here. So something like that. Let's get a few points. So 0, -1. Then you're going to have 3, 5. Then you're going to have 7, -4. Then you have 9, -2. Right, I am dealing with a polynomial of sorts. right? So I am dealing with a situation where I'm going to increase here because I know that I'm increasing because my derivative is positive until I get to 3. So I increase until 3 and then I decrease in between. And then I'm going to increase again. I could also go as far to analyze concavity also, but I'm not going to go through all that process just yet. But that's how I know that I'm not going up above to get back to this point, because I'm increasing, then I'm decreasing till I get to 7, and then I'm increasing to 9. So that gives you a general shape of the graph.